Okay, tell you what, if we look into the subject of gravity, and this is also another realm where differential equations can lie. And now, in the case of gravity, let's say if you have, okay, of course, regarding falling objects, and let's say that you have where differential equations are involved. And let's say that an object is dropped from a tower and we'll say that the tower stands 1,000 feet. And we can have posed some questions. Okay. And among the questions posed will be, how long will it take the object to hit the ground? Also, at what velocity does the object strike the ground? Okay, so we're looking at the English system of units. And now, in the case of what we have here, okay, so we have from taking what we have, okay, so we're looking at a 1,000 foot tower. And now we looked at correlating, okay, velocity, acceleration, and distance. Now, for this particular problem, okay, so we have change in velocity with respect to time. Okay, we have okay, it's going to be the acceleration, and now we're going to be looking at say, since we're looking at a falling object, we'll say we have the negative of the gravitational constant. And in the case of what we have for the English system, okay, so the gravitational constant we have at 32 feet per square second. Okay, and again, we just record that as negative 32. And if I take what I have here and express in terms of the differential of the velocity, so I have dv is equal to negative 32 dt, and separating the differentials, okay, so I can integrate on both sides. Okay, so we have for the antiderivative, okay, so we have velocity is equal to negative 32t, and we'll call this plus c1. And now the object is dropped. It's not thrown up, it's not thrown down. So we have for the initial velocity, okay, we have it 0. And so for what's going to happen in effect is that, okay, the constant is going to be negligible. Okay, so at time 0, okay, have negative 32 times 0, so that's going to be negligible. So we have a negligible constant. So for what this will signify is that we have, for the velocity, okay, that is equal to negative 32 times t. Okay. Now, in terms of where we have the distance, and again, velocity is going to be change in distance with respect to change in time. Okay, so we have negative 32t for the velocity. And as we separate the differentials, okay, so we have dy is equal to negative 32t. And separating the differentials, again, we can integrate. Okay, so for the antiderivative of dy, okay, that's going to be at y. And for negative 32t dt, antiderivative, we're going to have negative 16t squared. And we'll say we have plus c2. All right, and now, again, just from the start, okay, so you have an object is dropped from 1,000 foot tower. So for the initial height, okay, for the height at time 0, okay, that's going to be at 1,000 feet. So you have 1,000 is going to be the value of the second constant. And so we have in terms of the equation, okay, regarding the distance with respect to time, okay, since the second constant is at 1,000, okay, so we're going to have that y is equal to negative 16t squared plus 1,000. Okay. Now, in terms of how long it's going to take, okay, for the object to strike the ground, excuse me. Okay, so we have for y of t. Okay, so y of t is equal to 0. Again, ground level, we have it 0. And we have 0 is equal to negative 16t squared plus 1,000. And just itemizing, okay, so we have 16t squared is equal to 1,000. And so we have for t, okay, since we're looking at time, we're not interested in negative quantities in this case. Okay, so we have for the amount of time, so if I take the positive square root, 1,000 over 16. Okay, now for the amount of time, okay, we have about 7.906 seconds. Okay, and so we have taking what we have with the amount of time. Okay, so this will be about the amount of time it's going to take for the object to strike the ground. And so we have that. So whenever the object strikes the ground, okay, we're going to have, in this particular regard, okay, so just looking at configuring, going back to what we had originally for the velocity equation. So we have v is equal to negative 32t okay, and so just taking what we have, here, so we have negative 32 times 7.906. And so we have for the negative product, so you have about negative 252.98. And so for what this means in context is that we're looking at, okay, the velocity is going to be about 252.98 feet per second downward.